Hey there, future scientists, it's Emily, and we're back at Crest. And today I'm going to show you guys how to do a chromatography experiment. Today's experiment is going to show you how to separate marker pigments using coffee filter paper. So what I did is I went ahead and I grabbed a handful of colorful markers from home, and I also went to my local grocery store and bought a packet of coffee filter paper. The first step that we're going to do for today's experiment is that for each individual colored marker, you're going to grab a single piece of coffee filter paper and we're going to outline or draw a circle using this marker around the center of the coffee filter paper. And then we're going to write what the color is in the middle using pencil. So let's go ahead and do that. After you've drawn your circle around the center of each of your coffee filter papers, it should look something like this, and you should have the name of the color that you drew the circle with written in pencil in the center of the circle. And so the next step is we're going to prepare our pieces of coffee filter paper for testing. And we're going to do that by folding these pieces of coffee filter paper with the drawn circle on them into eighths. So we do that by folding it in half first, and then we fold it into fourths by folding that again, and we fold this in half into eighths. So by the end, depending on how many different colors you're testing and how many pieces of coffee filter paper you have, they should all look like this triangle pizza shape. And now they're prepared for testing. So next, you're going to go ahead and you're going to grab the number of containers you need for each piece of coffee filter paper. So I'm testing 6 of these guys today, 6 different colors. So I'm going to grab 6 beakers or 6 different containers. You don't have to use a beaker, you can use any type of container you have at home, just anything that can fit the coffee filter paper inside of it. And the next step we're going to do is we're going to choose our solvent. So today I'm using Crayola and Play School markers, and these are both washable markers, which tells me that their ink is, they have water-soluble pigments and ink. So I'm going to be using water as my solvent today, and I'm going to fill each of these beakers with their individual pieces of coffee filter paper with water, just so that there's enough water in the container that the coffee filter paper is immersed in it, but not too much water so that the water is at or above the level where I drew the marker. I use the marker to draw my circle or my line. And so after I fill each of my containers up with just enough water, we're going to see something called capillary action occur, and that's where the water is going to move up the coffee filter paper over time, and it's going to push those pigments from the ink that we drew in each of the marker colors up the coffee filter paper and spread them out in a way that we can see each of the different pigments and the distance that there are affected, their retention value factors, or we'll talk more about that. But we're going to be able to see each of the pigments spread out, and we're going to be able to identify the different colors that are within each marker. As you can see, I separated each of my pieces of coffee filter paper into different containers, and I filled them with an appropriate amount of solvent. And within a matter of seconds, the water has already begun to push the ink from the coffee filter that was drawn onto the coffee filter papers up. And in a second, we're going to pull these out of the beakers and we're going to dry them, and then we're going to take a closer look at all of the different pigments within each of the different types of inks. But as you can see, this is a process called chromatography, and it has already shown us that it's successfully separating all of the separate pigments that are within each marker's ink or dye through this experiment. After you let all of your samples dry, we're going to take a closer look at each of the individual pigments within each of the marker's ink and how different factors that play into how different pigments were spread throughout the filter paper. So the first sample that I want to bring up is my black marker. So I used a black marker today, and this is what it looks like after undergoing chromatography. And as you can see, it's not just black pigments. There's some brown, there's blue pigments, there's red pigments, and they're all spread out in a way that reveal different things about each pigment. So the reason that different pigments are revealed and different colors are revealed through this chromatography process is because some pigments, depending on which ones they are heavier or lighter, meaning that they have smaller or larger molecules, which affect how smaller molecules tend to be at a greater distance away from from where they initially started, whereas larger molecules or stuff that is heavier pigments tend to remain closer to where they were originally drawn. Additionally, depending on how soluble the pigments are with water, they traveled a certain distance. So as you can see, it's not just, but one of the most surprising things is that it's not just black ink, our black ink and our black markers that we use daily to draw. It doesn't just contain black pigments. It contains a variety of other different colors that have been revealed to us through this experiment. Moreover, we have our blue marker, which revealed different pigments of purple, lighter shades of blue, even some pink, and our pink marker, which revealed different pigments of mostly just pink pigment, but also some orange and red in there. And I also tested our green marker today, which revealed mostly just green pigment, but there is some shades of blue pigment in here, but this is what it looks like. And our orange our orange marker revealed mostly orange pigments with some shades of darker orange and some red pigment. Yeah. Earlier I mentioned something called a retention factor value, and in chromatography the RF value is the distance that the pigment travels divided by the total distance, or the distance of the pigment and the solvent combined. In today's experiment, unfortunately, we are unable to test the RF value because we used a circular piece of filter paper, which makes it really difficult to measure the initial distance from the final distance and measure the distance that the pigment traveled by itself. If we were to have used a long rectangular sheet of chromatography paper, we would have been able to measure and calculate the RF value. Unfortunately, we are unable to do that today. Today's experiment was a great introduction to chromatography. Chromatography is a method used by scientists to separate organic and inorganic compounds so that they can be analyzed and studied. By analyzing these compounds, a scientist is able to determine what a certain compound is made up of. Today's experiment was a basic breakdown of chromatography and taught you some of the fundamentals, but I definitely think that it is an important method that can be used and applied later on in life in your own labs when you're conducting your own research and studies. If you enjoyed today's experiment, feel free to share it with friends and family members, and you can try it at home or come here to Crest. And overall, thank you guys for listening and watching. Make sure to like and subscribe, and I can't wait to see you guys next time.